Good morning. This is Tuesday, April 5. Happy Cinco de Mayo to you all. And we are covering the fifth of five IXL skills that, when averaged together, will get you a test. And all of these skills are due as of this Friday, May 8th. And at that time, as you know, I'm going to go ahead and average the scores that you have completed for these and give you a grade based upon that for a test. Now, if you don't get these done on time, my suggestion is that later you do them, and just know that if worst comes to worst, you just have all kinds of issues that you weren't able to that forced you not to be able to get this done. At the end of the day, even if the scores that you get today are low and therefore bring your grade down, that will only be a temporary thing because you are guaranteed your third quarter score. So unless you're trying to preserve what you've gained, there really is no reason why you shouldn't be able to go in and take a chance and do these. So make sure you're trying to get them done. All right, so what are we doing today? So we're going to be able to find the roots of factored polynomials. And so the definition that we use here for zeros is the function of the output of x is a polynomial, and c is some real number such that the function of c, or the output of c, equals 0. And so therefore it's called a zero, or a root of the function of x. Okay? All right, and we'll show you this, of course, so that, if it's a little bit difficult for you to follow right now, you'll be able to better understand it. Okay, so here's the factor theorem. You've been exposed to this. We've done these before. It just simply says that the binomial, and a binomial is nothing more than two linear terms. So you can see this is a linear term because it has a power of 1 for each of these two factors that are inside, well, not factors, but two terms that are inside the binomial. So it's a linear factor of the polynomial of the function of x if and only if c is a 0, or root of the function of x. Okay? All right, so we'll see what that means again as we move along. All right, now let's go on and take a look at, oh yes, don't forget our favorite page, my favorite page. I want you again to use a sheet of paper with plastic on it so that you can write these problems out. If you don't do that, you're shortchanging yourself, and you're going to make it much more difficult to get a higher score. All right, so get this, do it, it's erasable. That's what you want. All right, so here is the first example that we've got for today. We're going to find the roots of the following factored polynomial. So here's a polynomial, and it is factored into x times x plus 6. Now remember, a factored thing is something where you broke it apart, and you can put it back together again by multiplying it back together. So if I use distribution and multiplied x times x plus 6, I would get x times x is x squared, and x times 6 is 6x. So that's the unfactored form of that polynomial. But the more important thing really is, how many roots are we talking about here when you're looking at factored form? So some people look at the number of binomials and they say, oh, there's only one binomial, so there can only be one root. Not quite correct. The thing you look at is the number of x's. How many x's do we see here? We see 2 x's. So since it's 2 x's, we know that there's going to be 2 solutions, and coincidentally, any time you have 2 x's, that's and they're of course multiplied together like this, x times x is x squared. So this is really a quadratic polynomial. All right, so we know we're going to have 2 answers. So you're going to write your answer as a list of values separated by commas. So there'll be an x value and then a comma, another x value. So first we've got to identify the factors. And then we're going to use the factor theorem to find the roots. Okay? So to identify the factors of x times x plus c, just break these apart to the two respective x's. You've got an x by itself, and they put it temporarily here in parentheses just so that you can see that it is going to be multiplied to x plus 6 eventually up here if we were to go backwards. So the factors are x and x plus 6. Now we want the roots. So since we know that whenever we've got a 0, then the output involved is 0. So since x equals x minus 0 is a factor, 0 is a root. Okay, somebody's going to look at that and look at me and say, what are you talking about? Well, if I were to take x, okay, and I don't have anything else with the x, unlike the second polynomial over here where I do have something, then I have to assume that instead of a 6, there's only one possible number I can have with the x, and that's 0. So this would be x minus 0 equals whatever your output's going to be. So what do? You add 0 to both sides, and so you get x equals 0. Okay? And it's the same with the x plus 6. Since x plus 6 equals x minus negative 6. Now, wait a second. Where did we come up with that? Well, remember, we're using x minus c when we're coming up with these linear factors. Now, why are we doing that? It's because, again, working backwards, you're trying to find out what x is when y is 0, so you end up having to subtract a term from both sides. So if I have x plus 6 equals 0, then I would subtract 6 from both sides, and I'd have x equals negative 6. And that's our root. And in fact, that's what this says here. So this is why you have x minus negative 6. It's because they're acknowledging the fact that to get back to, if you're going backwards, you have to subtract a negative number to get back to x plus 6, just working backwards. So don't get too hung up on this. Just follow this rule, recognizing what you're trying to do is to get to zeros. And so the zeros are 0, and there is the 0, and negative 6, and there's the negative 6. So that's all you're doing. Okay. I'm going to give you another one. I decided I'd give you several examples, so I'm giving you 3. So in this one, we're going to find the roots of this following factored polynomial. So this one is one you're used to seeing. It's 2 binomials. A little bit easier to understand. So I just simply take the first binomial, x minus 3, and I'm going to make that equal to 0. You're accustomed to seeing that, okay? Because remember, the 0 property rule says that if these 2 binomials multiplied together can equal 0, or in other words, if y is going to equal 0, that's what's happening here, y equals 0. Then x minus 3 can equal 0, and x plus 5 equals 0. So I want to get x by itself. I add 3 to both sides, and the 3 and negative 3 cancel, and I get x equals positive 3. So I'm going to write this here, positive 3. And then I'm going to subtract 5 from both sides over here, and I'm going to get x equals negative 5. So 3, negative 5 is what you get for that. Okay, so that one is a little bit easier to follow, but it's the rules we've been using cover this and all the other ones. It doesn't change. So if you just know to follow this kind of rationale, you're going to be good. You don't have to get too hung up on the theory, but the more you know, of course, the easier it's going to be for you. Here's the last one. So I deliberately chose this one, x times x minus 4 times x plus 3, because I've got an x over here again all by itself. So we have to assume that that's really x minus 0. Okay? X minus 0 times x minus 4 times x plus 3. So I would write out here x minus 0 equals, and again, what is y equal? Y equals 0. Right? So then I add 0 to both sides, and of course 0 plus 0 is 0. So x equals 0. So that's my first answer. Now, how many answers do you think you're going to have? Again, we've got two binomials. Does that mean we have a quadratic equation? These are both linears. Answer, no, because we count the number of x's. That determines how many solutions we have. So we have 1, 2, 3 x's. We're going to have 3 solutions. So we know what the first solution is, x equals 0. Second one, x minus 4 equals 0. Add 4 to both sides, and you get x equals 4. So your next answer is 4. And then your last one is x plus 3 equals 0. So that means you subtract 3 from both sides, and x equals negative 3. So there are your 3 solutions. And of course, again, if you're trying to ask yourself, if I have 3 zeros, what kind of a polynomial do I have? I have a polynomial whose leading term is 1, 2, 3, x cubed. Because x times x times x is x cubed. So this is a cubic polynomial. If you multiply it all back together, you will see that that's the case. All right, so that's it. It's not really too terribly difficult. Anyway, I think it isn't. But I'm sure you'll find that they're really pretty easy to do. Just use your old friend, the calculator. Take your time. If you need to, go back and look at any examples they have. And of course, whenever you do get one wrong, it shows you what you got wrong and why, and how to fix it. So you can do all of that. And you're going to want to at times you're going to get a low score. You're going to be frustrated. Maybe you keep making errors and your score goes lower and lower, and you say, screw it, I'm just going to stop here before it gets too bad. And well, you got a 35%. Walk away from it, but come back later. Go back and keep going until you get a score that's acceptable to you so that you can improve your grade. Okay? Be smart about this stuff. Use the time you have. We only have, after this, we have, after the 8th, there's just 10 days between the 8th and the 18th, and that's when we kind of, when we wrap up all the scores, and in a few more days we're done. So, be smart about this. Have a wonderful afternoon, and take care. Bye-bye now.